Welcome to Global Supply Chain Talk Show, Edition 11. Today, we are going to talk about one of the most important topic, high mix, low volume environment, how to achieve excellence through job shop lean. Okay, so I would like to introduce Dr. Shahrukh Irani to the show, and then I will give some briefing and about the topic. So, just to give you a very quick introduction about Dr. Irani, Dr. Shahrukh Irani is PhD in Industrial Engineering. He is IE faculty for 22 years in the Minnesota University of Minnesota and also Ohio State University. So he has a lot of research on the production flow analysis and simplification toolkits. So he owns a consulting company, Lean and Flexible LLC, to help organizations. And fantastic, he is author of fantastic books on cellular manufacturing system and also job shop lean. Okay, he teaches two courses, one in the Lean and another is about job shop, in the Department of Industrial Engineering, in the University of Houston. Okay, so welcome, sir, all the way from US to join the show. We are fortunate to have you here. Just to give you a very introduction about the show, the Global Supply Chain Talk Show series, what we do is we try to connect experts across the globe to the organizations who is looking for optimization and achieve excellence, whether it is in the manufacturing or supply chain or logistics. So with that intent, we have successfully done so many shows so far, and fortunate to have very good feedback, and many companies are getting benefit of it. Okay, so a few words about the sponsoring of the event. The Frusi MES is the sponsor of the event. So Frusi MES help organizations to achieve excellence in manufacturing, and also to connect every machine and the people in the work centers, and manage their manufacturing processes effectively and efficiently. Okay, we'll talk more about it maybe at the end of the session. So I take this as an opportunity to thank Dr. Shahrukh Irani to the welcome show. Dr. Shahrukh, please, I know this is a very important topic, and 30 to 50% of Indian manufacturing is on job shop manufacturing. So there is a tremendous level of inefficiencies in the industry. Even adding 3 to 5% of the optimization or improvement will tremendously help India in the manufacturing segment. So with this, Dr. Irani, please, you can start. What is it, and then maybe we discuss, debate about questions and how to do it, that kind of thing. So over to you, sir.
But first of all, thank you both to Mr. Sheikh Abdul Khader and, of course, Ms. Arigela Panwit Jyoti. You've been very patient with me, and it's a great honor to speak on behalf of your organization to the audience that you've attracted. Um I don't think that I'm an expert on this subject. I'm more of a irritant to a lot of people who think that if you do lean just because Toyota said something, that is the way you do it. My message to all of you will be: you are unique, and you're not a Bajaj, you're not a telco. They can get away with all their money and their consultants by implementing assembly line practices. No machine shop that I've been to, no heat treatment shop I've been to, no plating shop I've been to ever has an assembly line. And the moment you say you're a job shop, you should immediately say, how can I be a better job shop? How you don't say, how can I be a better assembly line? So that is the title of this presentation. And I will request Ms.
Yeah,
Jyoti to
Jyoti,
maybe
please
go
share the
live
screen.
with the
Yeah.
partner here to share the screen. Great. So this is the theme of today's presentation, and I will only go through the slides at a high level. Forgive me for that, because I would like to take questions from you to get a sense of where is your pain point, what are you interested in. The most important thing is understand, please, that I have put Job Shop in front of Lean. Simply to say, the entire world knows only one approach to improve any manufacturing system, and that is what has been popularly called Lean, which is a derivative of the Toyota production system, which again is a derivative of the real Toyota production system, because I do not think that Toyota has ever told the world everything about their production system. So I put Job Shop in front of Lean simply to say my ideas, my methods, my choice of tools are going to be for high mix, low volume manufacturers. What is high mix? Very large variety of part numbers. So look at yourself. If you're a machine shop, a heat treater, a plater, a grinding company, a steel service provider, look at how many SKUs you have, stock keeping units. Go to your shop. Do you see assembly lines or do you see forklift activity? So the idea of high mix is very large number of unique part numbers, and low volume means expect to have a lot of setups, because many customers will call you and say, hey, I want this order to be done by this due date. And then you're playing like a jigsaw puzzle. Oh, do I have capacity for this order? Oops, some employee went missing. My setups are high. My tooling breaks down. Those are the challenges of small to medium companies. So achieving excellence is a nice word. All I'm saying is, please understand that if you call yourself a job shop, start by saying, how do I improve my job shop, and not how do I become Toyota. Next slide, please. Next slide, please. Okay, that's about me. I don't need to give you a bhashan lecture about me. Those are just my credentials. All I'm saying is, you'll notice that I went from my PhD in industrial engineering, 22 years in academia, but I never had any industry experience as an industrial engineer. So here I was in academia telling industry, this is what you should do to implement industrial engineering, which is the core of Job Shop Lean. So the most important part in my career was when I quit academia and went to work in industry, and that was like a flash of light. So everything I do today is, as a consultant, I learn, I make mistakes, I learn, I implement, and then I carry that into the classroom and I teach industrial engineering graduate students. Most of them are from India. And I place them with internships and full-time jobs. And this is my advice to all of you. Please, please, please build a cadre of industrial engineers. Please don't say, oh, what is industrial engineering? Find out what industrial engineers do. They can double up as manufacturing engineers, but do not please think that getting some guy certified in Lean Six Sigma or some consultant from Japan who has worked at Toyota is going to help you if you are a job shop. So again, don't worry about my credentials. The message here is that you've got to understand industrial engineering from a hands-on perspective. Next slide, please. So here's an overview of Lean. Next slide, please. So this is important, as I understand that everybody is like, lean manufacturing is about waste elimination. Wrong, 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 wrong. Because waste is a symptom. It is not a goal. There's a cause. So your goal should always be, when a customer calls, regardless of the part number I have to make, regardless of how many suppliers the part number may have, I want to minimize the customer wait time, which is basically administrative lead time, the front portion when you're dropping the order, checking for materials, checking for suppliers, looking for available machine capacity, plus the actual production lead time. Once you drop the raw material on the floor, how much time does it take you to put it on the shipping truck that it goes to the customer? So please understand, do not get caught in this nonsense about doing 5S and going and eliminating waste. That is not what you go and tell the customer. We are very strong in eliminating waste. We are very good at sending you a part with the quality specifications fulfilled. None of our people died. We have full safety ergonomics. We met your due date. We had no expediting costs. We did not pay overtime. We are basically shortening the total time between ship date minus order receipt date. And eliminating waste is one of the ways that you shrink that total time. So please understand, the whole concept of lean manufacturing has been misinterpreted and I think missold, mismarketed. Okay. So your goal is not to eliminate waste. You'll get lost with where do I go? Your goal should be what do I do to reduce the total time it takes for me to get an order to the customer, regardless of which one of my 1,000 part numbers I have been asked to make. Next slide, please. So everybody, these charts are all over the web, right? Tim Woods, it is called the 8 forms of waste, Tim Woods. So D is for defects, O is for overproduction, W is for waiting. The non-utilized talent is what they call S for skills in that acronym, Tim Woods. Transportation is T, inventory is I, motion is M, and of course, extra processing is O. So it's called Tim Woods. Now, very nice graphics. I understand that there's a lot of waste, but you have to be strategic when you try to improve your job shop. And the last thing you should ever do is to say, I need to do 5S and I need to go and eliminate waste. No, you should step back and say, first question you ask is, why am I not able to fulfill any customer's orders within their due date, without paying overtime, without paying expediting fees, without having rework? Okay, you start there. You create what is called a mind map. Why? Then when you take action to eliminate the root causes on the mind map, you will find that is when you will say, aha, in the total time it takes me to do this, this is where the delays come due to any one of these 8 forms of waste. So that's my first message to you. Rethink lean manufacturing. Your goal is not to eliminate waste. That will come. Your goal is higher. I wish to fulfill any customer's order by their due date and make a profit margin without expediting, overtime, rework, and other delays. Next slide, please. So these are the principles of lean, and you must have heard about the Lean Enterprise Institute, lei.org. They were the ones who basically pioneered this word lean. And the only thing, one of the few things I have appreciated about what they have done is these principles of lean are a high-level 5-step strategic thinking process for planning any form of implementation of lean. So when I began my learning journey in 1999, and the Department of Defense came and said, hey, we need you to implement lean for custom forge shops. I said, oh my God, these are job shops, and they have got monuments, presses, and they've got batch processes like heat treatment and etching, and dirty processes like non-destructive testing. What do I do? Okay, I basically said, and I would advise this to you also, this should be your strategic plan, whether you call it Hoshin Kanri or whatever you wish to call it. These 5 steps are the core of your thinking process. So the first step is identify value. Not value from your end, oh, maximize profit margin. Value is for you, safety, quality, delivery, cost, throughput, the metrics that the customer cares about, right? So that's the first step. Please work with the correct metrics. So I would give you a very simple metric. Minimize the average fulfillment time, the customer wait time for any order. After that, you can use metrics like cash flow velocity, break-even analysis, value added ratio, but those are details. So the first thing is identify driving metrics for your organization that keep the customer in mind. Let those metrics guide your choice of in-house metrics and not the other way around. Let's eliminate waste, and that will automatically please the customer. Here's the catch 22. If you go to your customer and say, we are very good at eliminating waste, he or she will immediately say, okay, give me a cost reduction if you're so good. That's it. Boom. All your nice lean programs shot you in the foot. Second step is map the value stream. Now, in a job shop, that's a very difficult challenge, because for you, a value stream is a family of parts. And what is a family of parts? Those parts whose manufacturing routings are very similar or even identical. Because now, instead of looking at 1,000 unique part numbers, you might say, aha, I have 15 part families. And now your planning gets focused on, how do I have a standard way to produce each part family in its own little job shop? So you're getting what is called focus. And when you have focus, you can implement lean. So that's the second step. Identify the part families in your product mix. Third step is make the value creating steps occur in tight sequence so the product will flow smoothly toward the customer. What does that mean? That is basically in assembly line manufacturing, every step is next to each other. So what they are saying is, if you are making a high volume of product and not a high variety of product, it does make sense to organize the equipment to the extent you can, step by step, 10 feet from each other, so that every time you make a product, boom, it immediately goes to the next product and so on. But what is the higher goal? The higher goal for the job shop is change the layout so that the flow of your products in each of your product families is almost assembly line like. And how is that done? By implementing manufacturing cells. So second step told you part families. Third step said change the layout of your shop so that as much as you can, all your parts can be produced in certain work cells from a layout perspective. Okay? Fourth step, establish pull. At Toyota, established pull is very nice, because what they say is, when I shipped 10 units of this particular vehicle, they pull raw material and they say, please replace 10 of those units because they have demand. When you're a job shop, you don't know if that order you shipped has another customer asking for you to make the order. So what's the challenge for you in scheduling? It's a technique called finite capacity scheduling, where you release only those orders into the shop such that at the bottleneck machine, you do not have more than so many days of work in queue. If the queue is maximized, you stop releasing the orders. So you can see again that I'm following the principles of lean, but I'm using the methods of job shop lean. Okay. And the final step, seek perfection, is once again saying, once you have established your machining cells or your heat treat cells or your steel service cells, let the employee team grow, give them some autonomy, help them to manage their own business, give them a sense of identity. This is where all the tools like setup reduction, 5S, error proofing, visual management kicks in. And then you go back to step one and you say, okay, give me my next part family, let me implement the next cell. So this structure is very effective. The methods change, the technology changes, but I've always found this, that whether it's a job shop or an assembly line, this structure is what I call the principles of job shop lean also. So I found this very valuable early in my career. Next slide, please. So here's the origin of job shop lean. Next slide, please. Previous slide, please. Yes. So you will probably have seen this product process matrix in a lot of management books. Okay. And what has this matrix basically shown us over the last 100 years of manufacturing? They said that supposing you looked at all manufacturing companies and you said, okay, let us classify them on two criteria: the volume of products they make and the variety of products they make. So you see the x-axis says quantity volume, and it has two generic zones: low volume production, high volume production. The x-axis says product mix, variety of products they make. Again, low volume section, high volume section. So this matrix basically tells you there are at least potentially 4 types of manufacturing organizations: low mix, low variety, low volume; high variety, low volume; high volume, low variety; high volume, high variety. So you try to, if you are trying to say, I want to be Toyota, all you've got basically is a high volume, low variety production system. So if you are a
Correct.
different production system, a manufacturer, why would you want to implement the Toyota system?
Yeah.
If you look at the whole diagonal, all of these manufacturing / production systems are high variety and variable volume. They are not low variety, high volume. So this was my motivation for saying, gentlemen around the world, don't buy into this Toyota lean, blah, 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 only because Toyota concept is built around an OEM, an original equipment manufacturer, having complete control on their suppliers, on their dealers. How many of you have that liberty? Especially if you're a job shop, like Mr. Khader said, that 50% of manufacturing companies in India are SMEs, job shops. Same thing is observed in America. We are about 55% would contribute to the SME market. So all of them are running over, like falling over themselves to be Toyota, Toyota. And it's like, but sir, you don't belong in that sector. Look at this matrix. Okay. So you see on the right, Toyota is here. Where is that? High volume, low variety. And everybody else is high mix, make to order. Once you are make to order, once you have a due date on every order, you cannot apply high Junka. You cannot use
Correct.
Kanban because you'll go crazy trying to run that system. So there is much more detail. If there were more time, I would explain to you how even inside this, there's a high variety of production systems. My advice to all of you is, please, first understand the production system you have to improve. Understand your customers, understand your operations. Then you come back and say, okay, where do I belong on the spectrum? Then you start determining what flavor of lean you want to implement. Who knows? You might say Dr. Irani's stuff is useless. Very good. At least if I guided you to create your own model, that's what you want. You have to own your methodology. Next slide, please. So this is a heavy slide, but I want you to go to each and every block from up top right corner and then go clockwise around this picture in the middle. What am I basically saying? If you want to improve and you're a job shop, these are the actual challenges you may be ignoring. You cannot ignore even one of them. So each of these little blocks is an actual reality of the small manufacturer. So I'm not going to be able to go through all of them. You're welcome to please ask me questions later. We can have future webinars, whatever. But let's start from the top. Unreliable or incomplete demand forecast. This is on the top right corner. Which small manufacturer can say, oh, I expect customer Y to send me an order for part number X for 1,000 pieces? Forecasting is only for high volume products where you have so much demand data. You can track a time series and you can say, okay, if I go plus and minus on average, I will be able to sell that product. In a job shop environment, you don't have that luxury. If you did
Correct.
runners, repeaters, strangers analysis, you might find on a volume criterion, maybe 5% of your product mix is high volume. So with those customers, you can have a long-term agreement and you produce to Kanban. What about the other products? Right? You have to be flexible. So that's the first challenge. Ask yourselves, am I using my ERP system's forecast to drive my business? In which case it is suicide. You just jumped off a cliff without anything to save you. Okay. Second, suppliers do not deliver the right quantity at the right quality at the right time at the right price. That's the second block on the top right corner, right? You ask yourselves, do you get always bar stock with no porosities in them? I had a customer, a screw machine shop customer. They had what the mill did, what the steel mill did, they sorted out all the kachada pipes with porosities and defects,
Yeah.
right? And they sold the nice stuff to their OEM customers, and they told the machine shop,
Mm.
look, take what we give you, or else we won't give you anything. So what did the machine shop
Mhm.
have to do? In their router, they had to put extra steps to put in like costing calculation
Clean it.
adjustments. Why? Because they would have, oh, first I had to take the bar stop and I had to machine off so much length because there was porosities. Oh, tool broke because it hit a porosity. I had to change the tool. So therefore, let me add more labor time to that particular operation. That's what happens. I had cases where the client would say, oh, guess what? The supplier just sent us a batch of steel. Two bars were bad. So I'm going to have to split the batch for this order because, we needed those 2 bars also. Machine shop operator machinist falls sick. Okay, tool breaks, machine fails. Boom, right? The supplier says, what can I do? My problems are passed on to you. So when you go down this thing clockwise, every one of these, please let me know if I'm wrong. I'm not saying I'm God, but I'm saying I've seen all of the, either I've myself experienced them or I've read enough from other gurus in the subject to be able to say, if you don't plan for these hurdles, these challenges, you're forgetting that you're a job shop. Next slide, please.
Correct, sir.
So that's what I have defined as a manufacturing strategy. Please, 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 don't just think that doing lean and drawing a value stream map and doing 5S and setup production is going to solve your challenges of being a job shop. Lean is just one element of the strategy that I have found to be necessary. And so I basically have felt that you need at least 4 capabilities. So the first thing, of course, is lean. Let's cut cost. Let us eliminate the unnecessary delays and costs that we call tinwood. Okay, transportation, inventory, operator motion, waiting, over processing, overproduction, defect. Less that. But look diagonally across. Focus. Try to plan your business around families of parts. Don't just go and say, okay, customer called. Oh, very nice, attractive order. But no, I don't know if the customer will give us the same order again. Oh, let's go make it. No, you have to have focus. So plan your product mix in such a way that whenever a customer order calls, you know that, aha, it belongs in this family of parts. So I have some past capability to make this new part pretty well. Don't just do, we have 1,000 part numbers, but many of them, maybe they get ordered once a year. Those are called cats and dogs. Don't go into that thing. Most job shops make the mistake, oh, I got some business. I don't know if I'll get other business. Let me make that part number. Step back and plan around, I'm not saying one product family, plan around several product families, but be very good and be completely organized down the supply chain for focus. That's why it's called focus. Okay. Fourth one is flexibility. You have to have the ability. You have to have the ability to change over and make a variety of parts. You need people to be skilled. Your machines need to be flexible. You need to have cooperation. You need to have communication. You need to have manufacturing execution systems. You need to have shop visibility. That's flexibility. You have to be able to say, this month I made A, B, C, D. Next month I might make W, X, Y, Z. No problem. My shop will change over. My people will change over. My IT system can change over. And finally, the fourth capability is agility, the speed with which you can change. And anticipation. Look, what if a fire occurred? What if a fire occurred? What would I do? So I'm not saying that you have to plan for doomsday scenarios every day, but be firefighters. Look at firefighters, the discipline they have. You think they know when they go into a fire building, a burning building, what exactly? It's the discipline, the teamwork, and that we will protect people and ourselves. That they just go in and they have planned scenarios in their mind. So 4 elements of your strategy, not just lean, have to be planned for. Cost reduction, efficiency, focus around part families, flexibility, capability to change over, agility, speed of changeover. Next slide, please. So here's the dangerous slide, and I know everybody's gonna want to kill me, even though you're in Africa or India. But here's the thing: your consultant will come in and tell you, "Oh, let's do 5S." No, no, no. You see on the left side. Okay, I agree that in one way or the other, these lean tools are important to a job shop also. But again, they have to change. When you are doing 5S for the same part being produced at the same workstation, but of course you can have a shadow board and say, okay, this shadow board will have this tool first, then this tool second. What happens when you have got 100 tools in a tool magazine of your machining center? Then hopefully, right? So, oh, sorry, I should use some Hindi, okay, or Tamil. But the left column is fine. Even I agree that these are very good. But again, as an industrial engineer, these are just little pieces of entire subjects. Like setup production, there's a whole area called work study, time and motion study. Just saying setup error proofing is a whole subject called quality control. But the beauty is that Toyota taught me this textbook theory is okay. This is how they implement my IE theory. To me, that's the beauty. That was the dum-dum, slap around the head. But I'm like, aha, Lean and Toyota are teaching us how to make industrial engineering work. But look at the right side. These are all the tools you're told to implement which just don't fit into a job shop. What do you mean one-piece flow cells? If I have got saw in one area and 200 feet away, there is the lathe, I can't do one piece. I can't cut a piece of bar stock and throw it across from the saw to the, hey guy, catch, start machining. That is nonsense, right? Assembly line balancing, value stream mapping, takt time. What takt time? I have a due date. I have a batch of 5. What takt time? I don't make the same part. Different parts have work content differences. So why are you adopting lean when all these tools you've been told to implement are wrong? They're outright wrong. So that's what Job Shop Lean is saying. Please, people, if you're not Toyota, step back and find another production system. You don't have to listen to me. You develop your own production system, but for God's sake, don't jump in and listen to your consultant who says, we have to do 5S. 5S is like a lower portion. Have you got a factory layout in mind? Do you know the products you are making? Are your machines designed for flexibility? Only after you make those strategic decisions, then you go and do this basic level like 5S and Pokayoki. And the most important thing though is people. You will not find me ever arguing against the importance of people. But there again, operators are smart. They know when there's nonsense being told to them by the consultant or their owner, but they will shake their heads and quietly and they'll do things. Don't allow that to happen. Give them a platform to speak. That's the other thing I learned going to industry and lean. I, as the industrial engineer, am not a hotshot. I'm just a servant. I go to the floor and I act as a bridge between management and employees. And I keep it honest. And I'm always saying, do no harm. In the Bible, there's a saying, do unto others as you would have them do unto you. That's my driving principle. And I hope you'll follow that. But again, this is all the nonsense your consultants will tell you who've come from Japan or wherever, and all they know is the assembly line lean. So this is why I reject lean. Mm-hmm. And I'm basically saying, I have found my own methods, and that's being an industrial engineer. So again, my opinion, you don't have to, you find out from your own experience if you agree. Next slide, please. So I'd like to stop here. If there are questions, I would like to answer them. If there are no questions, I'll go to the next step, because again, the presentation gets more and more detailed. And, I don't know that in 2 minutes, I can explain to you how to implement work cells. So as I earlier said that I want to talk, but it's useless for me to keep talking. So at this point, I would like to stop and maybe ask the moderator and Mr. Khader to please, if there are any questions, please ask those questions.
Definitely.
I'll try and answer them.
Yeah. So basically, you have very clearly explained the initial challenges. Okay, so one of the challenge what I would like to ask you is create a flow.
Yes, sir.
Okay, so create a
Yes, sir.
flow. So now what I have experienced with visiting so many plants is they don't actually care about the shop floor at all. Okay, so all they care is the orders,
Yes,
the customer
yes,
orders, and then the delivery.
correct,
That's it.
correct,
Okay,
correct.
and I have talked to so many business unit heads that what is happening inside the shop floor they don't really care.
Hmm.
Okay, but they always have a problem of their the cost
Yes,
overruns, the capacity, idle
yes, sir.
capacity. They have a problem, and all those
Yes,
stuff.
sir. Yes,
Okay, so creating a flow is not one-time
yes,
job; it's a continuous
yes,
evolution.
yes, yes.
Okay, so this is exactly the problem, sir. What do you advise for that? Because this is one of the most important part for the plant managers or the owners.
So, so here's the point that because they don't care, that's why they have those problems. You know, you have to look at yourself in the mirror. That's the problem. That see, if these owners have the ego where they're like, don't tell me that I should be the one who should make the first difference, they just they just gave the answer to your question. Everything that is happening that they're ignoring is why they're complaining. What you think cost overruns are eliminated by magic? No. You think that quality defects are eliminated by magic? No. But who do the employees respect? The person at the top, right? If the person at the top, so I'll give you my experience with what was my most successful implementation. In 18 months, we moved the entire machine shop of a local company called Superior Completion Services. And you know who I give credit for the success? Their director of manufacturing, Todd Crescian, not me, not me. Because what Todd said was, you teach me what you are doing or asking me to do. Until I am convinced, I will not support the implementation on the floor. Right? So the thing was that the big man, the guy who had the most influence, he was the bridge. The employees were like, fire this Irani guy, he's making us do things differently. I hate him. This, that. He said, no, but what is your problem with what he said? Tell me. And it was always every time they had a, oh, we don't agree. He said, but do you see what he's proposing? If you do what he's proposing, that problem will be addressed. And so, you know, this thing which you said that they say we don't care, hello, that's the root cause. Because if people on the floor see the boss man coming, both say the director of manufacturing and the plant manager, they are walking the floor daily and they are going to machinists and saying, I like what you did, or could you please change that, or what are you doing? You can get hurt, right? People now know they cannot screw around.
Okay.
Forgive my French. Okay, they know that I can't just sit around behind my machine chewing pan, whatever. You cannot. But at the same time, the management should know we are not going to punish our employees. And so when they have a suggestion scheme, they respond and say, that's a gold medal suggestion. And a little thing is given, like a gift check, a lunch with the boss or something like that. But going back to your question, if they think that magic will happen because they are managers and just have to say, give me margin, good luck. Good luck. And if they think a consultant will come and do it for them, good luck, because the employees will say, who the hell are you to tell us what to change? And who are you to bring us the word of God? It has to be owners, consultant, people with a strategic plan, and there has to be accountability. Where are we today? What had we planned to do? So I'm telling you, final answer is that these people who are saying that they are unhappy because they're at the top, they have failed in their responsibility. So look at yourself in the mirror. If you don't learn to implement job shop lean or whatever is needed, if you aren't prepared to stand up and say, sorry guys, wrong decision, I would have done it differently, it won't happen because people respect the people at the top. And until you bring them yourself down to the floor, that humility, sorry, but you will, why do we have overtime? I can draw a mind map for you and say, here's all the reasons for overtime. Will the people accept that? Oh, it's okay. We charge that to the customer. Tariff we put on the customer. Overtime. No. One day the customer will say, you know what, you're overpriced. Bye bye. I'm going to China.
Correct. That's exactly the problem. Yeah.
Next question.
So Faisal Ziauddin, wondering what a good methodology to form pot families at the time when an organization decides to move from job shop to manufacturing cell.
Okay. So again, please, I'm not marketing my software. Okay. So all I'll tell you is what I know. And what I know has already been solved from 1960s by Professor John Burbidge. So there are two approaches to form part families. One is will require somebody with skills in machine learning and data science. Okay. I'm sure at IITs and other places you'll have gurus in that area. So that approach is called group technology. There are books on that. Okay. There's a method called cluster analysis. You can do that. But it's a little more data intensive. Hmm? But the approach I use is a method called production flow analysis, and we have a software called FAST, which you can buy for $100, which people find too expensive. But with FAST, all you need is the sample of parts, the routing of each part, the work centers which feature in the routings, the layout of the shop, and for each part number, annual revenue from sales, and very basic data. It's called the FAST input file. So if you have that data, Fast is a little old, but you could run at least 1,000 part numbers through it, and you can process the output into form the part family. So uh, the good news is that the software works. The bad news is that you'll have to learn and be patient with the outputs you get, because you are not going to see Jadoo Kalimantar type of part families as soon as the output comes out. There's going to be so much noise in the data because your routings are messed up. You know, so many companies, when I say, sir, do you have routings? Yes, it is a saw, lathe, mill, grind, inspect, ship. But sir, which saw? Is it a large capacity bed saw, small saw? Oh, we don't know. We just put the bar stock and the department supervisor picks up the pallet and puts it on some saw. That's not a routing. Sir, what about turning? You've got turning centers, you've got large bed lathes, you've got some conventionals. We just, that whole batch is produced, bar stock, and we put it into the turning area and the supervisor picks up. No, you need to have actual routings where, I'll give you an example of routings. So let's say you've got three saws. Depending on the length of bar stock and the quantity, you might say, I go to the large capacity saw, and there's one of that. Or I go to the small saws, there are two of that. The routing should reflect that. The routing should reflect that. Small saw times two, large saw times one. Same thing with turning. Conventionals, pure CNC lathes, or turning centers. There are three choices. So if you have your data at that level of correctness and accuracy, boom, with fast, you can be in business within 2 days. All you require is install the software, have correct data, and again, it takes time to learn how to use the outputs. I'm good today because of all the bumbling and learning I had to go through, but learning is learning. Within about two projects, your fundas will be straight. Uh, and if you hire industrial engineering interns, graduate students, they are like knowledge hogs. They'll know data science and programming, boom, 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 between yourself and, even one industrial engineering graduate student. This stuff is like doable. So I would use production flow analysis, but again, please don't think I'm trying to sell the software. You can use group technology, but it's a little more challenging, but it can be done. And I'll be happy to share the books on that approach. But there are two methods: group technology, production flow analysis. I've never used group technology because as a consultant, you need to be fast. It takes too much time. Production flow analysis, they've given me data. If they have it within 2 days, I've cleaned it up. By about 2 days, I'm ready with the outputs to start doing my Kaizen or whatever they want, either remotely or on site.
Yes, sir, please. Please proceed. Yeah, you can continue, sir.
Okay. Okay. So job shop. I'm sure that was the most important. So next slide. So okay. So all I said here is that the same five principles simply change the methodology and the tools. That's all. Okay. So again, please bear with me. This is heavy. It takes a whole semester to teach all this. But for example, principle number one: identify value from the mindset of the customer. The first thing which you do is to do what is called runners, repeaters, and strangers analysis. Why? Because runners are these are confirmed high volume Kanban type part numbers. You want to do business as much as you can for those part numbers, right? What are repeaters? I don't have a consistent Kanban like pull in the demand, but I always get orders for these customers. So if I created a work cell around a group of similar parts from repeaters, no matter when the order drops, I can quickly perform start raw to finish the order for those parts. Strangers are what some books might call cats and dogs. Okay, these are your losers, meaning that you don't have the skills and your operators forget to make the part, and so when the next time the order comes, they make defective parts because they forget they didn't capture the tribal knowledge for those parts, so they are relearning, like, how did I do that, what fiction did I use, what were the number of passes, the depth, blah blah blah. In the process, either it takes too much time or you get scrap. And when your raw material is titanium or Inconel and you get scrap, there's a lot of concern around the shop. So, identifying value from the customers is basically saying, do I know my segments, runners, repeaters, strangers? Because
Correct.
the value you get from producing cats and dogs is zero. And the value you get from the runners is max, but they are not the biggest portion of your business, right? So that's the first principle implementation.
Sir,
Yes, sir.
one example. So I had one client in auto
Yes,
tire
sir.
one manufacturer. So
Yes,
they
sir.
had runners and strangers. So they were
Yes, sir.
giving all in the same priority. Okay. So first come
Uh,
first serve in the scheduling. So they had a big
yes,
problem.
sir.
So one very simple application, simple process is, so you don't mix up them. Okay. So strangers,
Exactly.
it is not in rush. It's after sale service parts kind of thing. So you dedicate
Yes.
one day for them, and then all the
Yes.
rest of the days you do runners. Then
Yes, sir.
dramatically the process has been changed. So it's very
I,
simple. Yeah.
I know.
Mhm.
Yeah. And again, I guess they're tier one. So for them, you could do a high junker. So I guess, yeah, I don't know about high mix flow lines, but again, see, this change over time and the run length is very important because, see, I like when I did a project with extrusion, like they were making cables, right? So there was the first machine was the extrusion, the plastic extruders, right? Which melted the plastic and rolled that around the wire, correct? So they were changing colors without looking at the spectrum. So the purge time, the amount of plastic they wasted to purge the mold, right? The extruded mold
Mhm.
to change the color and go to the next. You could see all that plastic on the floor.
Waste.
Yeah. So the whole idea was, okay, let these extruders do these colors on this part of the spectrum. Continue, sir. Let these extruders do these colors. Don't change. Just don't say, oh, each extruder can do all the colors, and then you waste so much plastic. The pellets, right?
Correct.
So I think that again, tire manufacturing is probably a very high volume, but to your point, you are absolutely right. High volume line should have low mix, low volume line should be high mix, but check out the setup issues that cause defects in setup time and then change. There's a concept called production wheel. So that could be used visually, that check the color, and then if there's a high separation on that wheel, look for the next order, pull the next order in. So that would be one way at tier one level in a highly continuous system like tire manufacturing. That would be one of. I don't know about highly flexible tire manufacturing cells. I don't know the technology, but you're right. That was a very good thing to do.
Okay. Please proceed.
Okay, so principle two is basically talking about creating a part families, right? And again, it's all industrial engineering. It's all bringing together TOC. My belief is I will use whatever works. I'm not going to reject something just because it is Lean or Six Sigma, but I will not glorify as people do. Oh, Lean Six Sigma is going to solve your problems. I'm sorry. All that is low level industrial engineering. And everything I know in industrial engineering, I can teach you under Lean Six Sigma certificate. So be careful. Please don't hire certificate holders, hire real engineers. Okay. And that is the challenge you have working with your IITs and other institutions. I don't know. I come from India. Okay. So I just believe that your top higher education institutions don't have good industrial engineering programs. So either you create them with a local consortium or you partner with the IITs to say, hey, when will you get real? Okay.
Mhm.
Um, okay. Principle three, same thing. I mean, it's your work cell is a manufacturing system. So you want to maximize the capabilities of the group of people and the machines working there. So you can see, I've basically said it's not magic. You know, when you run fast and you think the part families will be immediately obvious, no. So in chapter 16 of my book, I've clearly said these are all the continuous improvement activities you will have to do to actually create cells. So, you know, I'll be very honest with you. This is hard work. It's different. And if your fundas aren't straight, don't undertake it. Because then there'll be frustration and you'll blame the fact that you didn't learn. The method works. It is not easy. It takes time, but it works. And I will be the first one to admit I've made mistakes, things haven't worked out, but I found the reason why it didn't work and I corrected it. So today, my whole mentality is oh, I started with this approach, but step three seems to be different. Change the step three. It takes time, it takes experience, but you know, it's doable. Okay. Principle four is basically scheduling. And you will see, I talk about water spiders, machine monitoring systems, manufacturing execution systems, ERP systems. Your IT systems are killing you. If you think that your ERP system does anything for production operations, good luck. Those ERP vendors are making money off you. Like those SAP guys, you know, they're running a little business. What they do is they say, no, 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 no. Our consultants will come and customize your SAP. We won't tell you how to customize SAP. That's a racket. And
Mhm.
the worst part is that even the best ERP system in the world is still running MRP, material requirements planning. That crap doesn't work. You can't schedule a job shop with a ERP like Oracle or SAP. So I don't know what ERPs you are buying, but if you think ERP is going to schedule, it doesn't. You have to look at things like Preactor, Asprova, Schedlizer, Dr. Prasad Vilaga. You know, his very affordable system is about, I think he said $5,000 for a small site. But again, it takes work. You should know, the person should know how to schedule, the person should know how to take the outputs and go implement them on the floor. But the future of Principle 4 in job shops is scheduling. The good thing is, I keep saying let's implement cells. Why? Because now the machines are all next to each other. So if any schedule disruptions occur, boom, 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 patapat, you can make changes. So principle four is saying, don't think that a machining cell is going to be schedulable if there are 8 machines that could run anywhere like 200 different part numbers on any given day. And principle five is simply the same thing that look, there are so many best practices you have to implement. And so don't think that just because you did step four, problems are gone. So my advice has always been take the pilot cell and
Mhm.
go the whole distance with it and keep sharing with the other employees what went wrong, what went right. My experience was when we did the pilot cell, other employees started looking at talking to their friends and saying, because the friends were saying, man, we get an order and boom, 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 we get it out the door. Inspection comes to our cell when we call it. Inspector has a granite table with all their micrometers and gauges. They check the parts, they give us feedback, and then they go back to the inspection department. No, Water Spider comes and asks us, when do I bring you material? When can I take your parts to the washing station? You know, so you get that pilot cell done, and then the word goes around. And that's what happened at Superior Completion Services. I would go around, even though as an outsider, I would go around with my Gemba walk saying hello, salam to everybody, shaking hands and all, right? And then they were Vietnamese, but they would, in English, they would talk to the plant manager who would say, hey, they're asking me, when will I get a cell? When will my machines be put in a cell? Seems things are good. So, success is contagious, but failure is also dangerous. So don't have this huge, we are going to have a transformation. Well, forget all that. Don't have big proclamations. Be humble, be small, be thorough, and be determined. So implement the pilot cell and share pros and cons. Complete open conversation. Do no harm. And it'll, like a virus, it'll spread in a good way. Next slide, please. So again, that's a big busy map. This is a chapter, there's a figure in chapter 2 of my book. Okay, you know how in academia, you have to make things very comprehensive, but when you make them comprehensive, it becomes confusing. And people look at this and say, let me get my Tylenol. I'm already getting a headache. Okay, but just understand, please, that this is doable. Okay, I can explain to you everything step by step once on the floor. And there's no magic here. But a flow chart is of course confusing, but you can see at the end of the day, 3 big steps. Segment your products, runners, repeaters, strangers. Find your part families. So the strangers, there's a paper which was published in an American magazine 1984 or something. The concept is called C cells. So runners, repeaters, strangers, right? So what they said was, we took all the low volume parts and we developed a standalone fabrication cell where all these low volume parts were made, and they trained employees in that cell. So once employees were trained in that cell, then they were sent to the rest of the shop, which had cells making the runners and repeaters. So their employees now are able to do flexibility and agility. Go into the runners and repeaters section. Okay, so that's the ABC analysis. Then of course the standard stuff: design the cell, schedule the cell, do capacity planning, and then go back and implement the next cell. So this was my version 1. Next slide, please. And go back, please. One slide.
One more slide backwards.
Go back, please. Okay, sorry. Next slide, please. Sorry, next slide. So this one is going to give you a bigger headache. Okay, but what I'm saying again is that, again, this is all doable. I mean, again, because when you have to put the whole process into a slide, people look at it and say, oh my God, it's very crowded, very busy. My point is that this is the second version where I'm like, I use this approach now. Okay. And, I can talk about it on a webinar. You have to do it. So, it's the same method, a little more detailed. And now you can see that I'm very clear about, this is what I do. So if you look on the right side, you see that diamond decision block. It says, is any product family left? And there's a question. Now you look to the left side, you see that strangers, you see the strangers, that question mark? That's the connection. What I'm saying there is that, welcome to the most difficult portion of your transformation. How do I produce orders for strangers? Part numbers which are maybe ordered once every 6 months. Should I even go into that business? Why do I produce this part number? One fabrication shop I'd worked with, their plant manager was really brilliant. No, wait, VP of operations. This was in Minnesota. So I said, sir, do you rationalize your product mix every year? Of course. We go and ask our accounting guys, our machine shop guys, hey, which part numbers are low volume, low margin, and the customers are hard to deal with? Dum. Okay, get rid of them. Make up the business for those parts with the other parts we make efficiently, whose customers pay us on time. So they call up those customers and they say, sir, we have hereby fired you. Thank you for your business, but we don't want to do business again with you. But guess what? He said, you know what we do is, to screw our competitors, we tell them, oh, why don't you go to these companies? You can ask them to produce these part numbers. Brilliant. Benefit yourself, harm your competitor. Why? Tell your customers you're a pain in the butt. You please go do business with our competitors. You transfer all your problems to your competitors. Brilliant business, brilliant thinking, right? So, most important for job shops, my suggestion would be control your product mix. Be careful about what you think you should make. And sometimes, again, you might say this Irani guy is drinking, he shouldn't drink stuff, right? See, when you're a small company, you don't have the clout of an OEM. But why can't you have a partnership with, say, other machine shops? And you create like a network, what I call a virtual OEM. So now you have a partnership where you have two machine shops and a common set of suppliers. When order comes in, you say, okay, give me one second. When you have an order come in, both the company owners or accountants or production planners talk to you and say, look, this part number seems to be something your shop is more focused on. You run that business. So my challenge to you is, what if the whole business model of the small company changed, where you said, hey, in my neighborhood, in my city, I've got two competitors, but since we are overlapping in what we do, what if we had a memorandum of understanding and we said, okay, we will move our part mixes across the three shops so that each shop becomes focused on a certain range of part families. And then you basically run the business as a virtual OEM. So you may be individually small, but now you bid to an aerospace company and you say, our virtual OEM, will make this entire range of parts for your planes. So, that could be a completely different mindset, where you go from being small to being big or looking big. So,
sir, I have a question, sir. Would you like to take it up, from
Yes, sir.
Faisal? Have someone quantified 8 waste happening on the shop floor worldwide? Say the loss in dollars or in time.
Sure. I mean, it's very easy. I mean, look, for example, take rework. That is very simple, right? Labor, materials, and overhead to replace the defect or scrap. But let's take, for example, inventory, dollar days of inventory. So what I have typically done is, I look at every order that is shipped. It has a selling price. So you basically say that year to date, I have earned so much on the books, and you divide that by total dollars invested to make the same parts. So that's a break-even analysis. So total revenue earned divided by total cost, you have a 45-degree line. And if after every order you ship, if that point is below, you're not doing well. If this point is above, you're doing well. So inventory, dollar days of inventory. Yeah, Goldratt, in fact, had come up with the idea. In manufacturing scheduling, there's a metric called weighted flow time. What that is saying is, at what rate did you earn dollars? So say you produce an order, you earn $10,000, but the total time in shop, right, including holidays, because that money is still locked in your shop, right? So 2 shifts a day, 20 working days, you earned so much dollars. Divide that by the total time the job was in your shop. That is your cash flow velocity. That is the rate at which you earned the money. So the higher that ratio, dollars earned per hour, the better your shop is doing. So it's all, your accountants have to give you the data, and many of them are like, "Arey yaar, I'm a CPA, don't bother me," because they don't want to go on the shop floor.
Yeah.
But the 7 forms of waste, each of them can be quantified. Operator motion, you put a video camera on the operator and say, look, I'm not going to punish you, but I want to get a sense of how much time your welder is arcing, right? You're a big welder. I'll look at the arc time. I'm not going to punish you, sir. Okay, I just want to see how much of the time was the arc not flashing. And then I want to know why. I'm going to come and ask you, look, when the arc was not flashing, I saw that you were talking to a friend. I'm not going to punish you, but do you see, welding is the bottleneck, and you're not giving me welding time. So every, operator motion waste, everything is quantifiable. The delicate issue is that some of the data requires observation. Some of the data requires being on the floor. And if you just go to your ERP system, your accountants are cooking up the numbers, right? You don't trust accountants, do you? Do you trust accountants? But okay, so my point is that every one of them is measurable. Now, skill, okay, that's not so much measurable. That will come about when you go to a morning meeting between management and employees. That's where you see the skill waste automatically. That's not measurable. That's a 0-1. The management simply shot down some employee suggestion. Skill is 0. That's the 8th waste, right? Not having him. But the other 7 wastes are very measurable. In fact, I believe that if you're familiar with discounted cash flow and analysis and activity-based costing and flow process charting, you can quantify the 7 forms of waste. But it's data collection.
Okay.
And if you don't have industrial engineers on the floor, that can't happen.
So that is one of the most important problems, sir. The resources. Okay. So without proper resource, and also with the proper investment from the management.
Yes, sir.
Okay.
Yes, sir.
All the things will be in theory. Okay. I think that's one of the main problems, sir. Yeah.
No, the thing is that I'm saying that we don't need industrial engineers. We don't even know what they do. You will get some nonsense Lean Six Sigma consultant charging you $2,000 a day. What nonsense is that? That guy is come from Japan. He has his own mindset. He just comes and forces you to do things that justify their time.
You're right.
How do you know that what they did for you was any benefit? $2,000 a day? Look at that investment you made, and you think you can't justify an industrial engineer from a industrial IIT? Like, for example, IIT Kharagpur, I think, is a very hands-on production engineering department. Again, I am not convinced that the IITs really teach real industrial engineering. They might teach some nonsense in the business school, but that's the challenge. The government has not told the IITs, we give you government money, damn it, produce good industrial engineers. And industry leaders are so off on a highland that they think industry is not important. Oh, we'll hire a consultant. I'll change leadership and culture. At the end of the day, it's boots on the ground.
Correct.
So if anybody says, I have justified an industrial engineer, not forget me, that kid has done it. Sultan Muhammad in 1 year took this company's shipment from $600, 600,000 a month to about 1.1 million. In 1 year. Why? Because he's a damn good industrial engineer and he has management support. And they never say employees have to be fired. When there was any issue from accountants, the CFO, oh, you have got too many heads, we repurpose the employees. So this nonsense about, we don't have resources, it's a mindset, it's an attitude. And especially India. If you're in America, they don't know what industrial engineers do, and they hire Lean Six Sigma black belts instead. What would that say about India or Pakistan or Middle East? The whole mentality is different. Oh, like you said, the owner said, oof, we only care about numbers. But you know what? But the very things you refuse to do was the reason why you're complaining that you're not seeing the numbers. So my advice, frankly, would be, is the company owner, CEO, COO, VP operations, director of manufacturing, plant manager, how many of them, look at all the money they are making, have they even hired one industrial engineer? A good manufacturing engineer? No, we don't have the budget for it. Right? So, if the upper guys, for the amount of money they waste, for example, okay, CEO, I'm a CEO, I can drink champagne, $2,000 a bottle, right? If that's the attitude you have as the owner of the business and you don't think Gemba walk is important, going on the floor, talking to employees, congratulating them, thanking them, that's where the problem starts. Internal talent. I'm not saying they should all be industrial engineers. One industrial engineer, one mechanical engineer, one data science person, babam, boom, boom. paisa will flow through. And I point to this young man, Sultan Muhammad. He's a hell of a good guy, no arrogance. He's bilingual, so he beautifully communicates with the 14 shop employees. The company makes 15 million a year. Chota company hai. But that's my model. I say, look there, look to the company. We are 1 year into our journey and look where we went in 1 year. They are making this location like a model shop. They're investing in the shop and saying, we'll give you the money if you can bring us to 2 million a month. That's our goal. Management gave us a goal, management gave us the support, we will do it. And what is our model? I, as a professor, teach my 2 classes with. So all the projects we do are driven by what Sultan needs help with. So nothing we do is buck. So look, Indian companies everywhere, Africa, you have to learn to work with the universities, and you have to be able to say, hey, government is paying you. What the hell are you doing for industry outreach? Oh, we are publishing papers. Who cares? Oh, we are publishing papers that discuss how we implemented our research at XYZ companies. Now that is real federal money going down to institutes of higher education, going down to industry. That is the secret.
Correct.
A consortium. But anyway, this is again, it's involved, but all I'm saying is that it's everything problem driven. The methodology is implemented and it's flexible, and it's all based on a 50-50 responsibility between the company and people like me. My bias has always been, let me teach some industrial engineers and put them on your company payroll. Let me work with your own people. Because as an outsider, I have the least clout. I have the least clout to influence. So without your help, the company ownership, management won't have. Okay. Next slide, please.
Yeah.
So again,
Perfect, sir.
This is, again, everybody, oh, Toyota this, Toyota that, and they build that house of Toyota. I've come up with something called the bridge of Job Shop Lean. I'll tell you why. Because you see those big pillars, the 2 big black pylons or whatever, So layout and scheduling. The 2 massive pillars are flexible cellular layout on the left and capacity scheduling on the right. Do you see the whole bridge itself, which says group technology using data science? That's the connection. Okay, part families. Now you're going from left side to right side. So you see all those big cables going vertically? These are all your tools. And you'll notice I have combined tools which may be called lean tools, Toyota tools with industrial engineering tools. So remember step 5 in the lean implementation process, pursue perfection. These are all the things you'll have to do. Do you see me put 5S there? No. Oh, it'll come. It's trivial. 5S is trivial. This is the real stuff. Manufacturing execution systems. Somewhere in the middle, see co-opetition. That's a technical concept, but what is co-opetition? 2 competitors collaborate. That's what I call the virtual OEM.
Correct.
Then there's a thing called 4H leadership. Actually, it's now 5H. So, a horse, head, hoofs, heart, hands, and ears, the ears, right? That's the leadership. I call that 5 H's. The head, hands, heart, hooves, because it has an H, but no leader is a ghoda or a gada, right? So it's like, okay, I don't want to say legs. It doesn't sound sexy then, right? Now 5H, I can say head, hands, heart, hooves, and hears. Listens to people. Hands, shakes hands with employees, says thank you to them. Heart, cares about the business, cares about the people. Head, themselves, they learn about lean. So, water spiders, again, if you take a machinist of the machine shop and you make them the logistics person, the metal handler, This person knows machines, they know parts, they are getting their priority orders from the manufacturing execution system. Fantastic. They are getting along with all the people on the floor, and you have the complete connectivity between operation steps for the parts. So this is what I call the bridge, and this would be your step 5. Once you've implemented the cells, all of this needs to be done. Digital process automation. But of course, if the machinist has to walk out to the supervisor's desk or the plant, hey, you know what, this tolerance, this drawing is outdated. Why should that have to happen? In the meantime, a $200,000 machine is idle. And if it's a Moriseki cell, that's $2.3 million. So, these little things count. You have to listen. You have to see. You have to talk, So you can see the bridge goes from lean to flexible. And that I think is important. That's why I tell people, I'm not going to come and sell to you Toyota Production System and the message of lean. I will sell to you what will work for you. And if it doesn't work for you, I will find what works for you. But I'm not going to sell you 7 forms of waste and set up production. I'll sell you a strategy and the steps necessary for you, because you said you are high mix, low volume, and the questionnaire that you submitted to me justifies that you are that way. So I always tell people, please understand what you are about, what you wish to be, and then what you need to do for your company, not Toyota, not Bajaj, not Telco, not TVS Motors. Next
Perfect,
slide,
sir.
please.
Yep. So few more minutes, sir. So
Sure.
yeah.
So again, the rest of the slides, like I said, this is, we could have a webinar on each step. So, find the metrics, find the part families, create the layout, do the scheduling, pursue continuous improvement, right? Step 1, 2, 3, 4, 5. I like I said, I didn't want to, blah, 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 but understand that there's very specific ways to implement each of those 5 steps, and they're all doable. Okay, so I'm not talking like an academic, that academic thing is gone, 15 years ago. 1999, I knew I was a failed industrial engineer. So it's been what, 25 plus, about 25 plus years of, how does the industrial engineer really do their job on the floor, especially high mix, low volume. So my book is what, if you use my book as a weapon of concussion, if you hit somebody, they would suffer concussion. It's what, about 700 pages. That itself today, I wrote it in 2020, it was published. Today I'll say it's obsolete, because so much of what I thought was all I needed to know, there's more to be done. So these 5 steps, they take a lot to implement, but every one of them can be done pakka. But if your owners are not interested in being involved, if you don't have industrial engineers, working with me, or you've got good industrial engineers from IIT or other engineering colleges, good luck. Buying some consultants' time with Lean Six Sigma black belt. Trivial, superficial. Okay. So so we can, each of these principles is a webinar by itself.
Mm-hmm.
They look daunting, all these graphics look daunting, but I'm trying to put into a slide which is all numbers driven. You give me a fast input file, I can run fast. All of this can be explained. So this is just visualization of, and if you go to extreme last slide, please, Ms. Jyoti, could you extreme last, just keep going to ekdam end tak jaiye, ant tak jaiye. More please, keep going, please. Okay, next one. Yeah, see, this is what I've said, that I've repeated the same slide, that when you are implementing principle 5, all of this stuff will need to be done and more. And so you need a top-down, bottom-up strategy, that you pick up one major thing to implement, and then you tell employees, we need you to do these Kaizans also. because some things you know well to do that we don't. And that is how the top down connects to the bottom up. Today, typical thing is you bring a consultant and it goes top down. Hey, this one is from Japan. Give them your time. Don't you question anything they say, right? That will never happen.
Mhm.
That will never happen. They'll just act, your employees will just act patient and then drop you. But
Mhm.
that's, thank you.
Yeah. Sir, what is a typical timeline you advise that if somebody wants to go for a transformation? Okay.
Yes, sir.
So, what is
Okay.
a typical timeline? Is it like a few months or how
Few
is that?
months.
So, how is that take up?
Okay.
Yeah.
Okay. So here's the thing. You are not going to get this done if you rely on a consultant to do it. So, for example, in my case, it took me 18 months and I was there about 2 days a week only, correct? It took me 18 months with a really good director of manufacturing who was completely sold on being successful. Okay. So budget ran out, I got fired. But of course, that's reality for a consultant. Took us 18 months, 2 days of my time on the month, and a full-time intern from University of Houston and Todd, right, to move every machine in the machine shop.
Mhm.
Okay. At McWane, which is much smaller, 12 million today, we are 1 year into the thing and we're still going. But you see, as long as management is seeing, my God, Sultan and the 3 plant managers and the 14 employees are doing things and they see incremental improvement, it's internal, right? They're not paying a consultant
Mhm.
like me. I'm doing it for my own academic gains, right? So it's continuous. I will never put a timeline because that becomes a consulting thing. Hey,
Correct,
you're
sir.
a consultant, you're damn expensive. You better be done in 6 months. So then what the consultant does is what will work for them? 5S. Are jharu maro there, paint over there. See, we transform the shop. No, it's just looking clean. Okay.
It's only clean.
So so my advice is you should measure timeline internally, not
Mhm.
from a consultant's point of view. This lean transformation is all hot air.
Mhm.
Oh, we'll give you a lean transformation. They will make money. No outsider should be given charge of your transformation. Your transformation will be determined by what you do, how much you put
Invest
skin in
time.
the game to implement and be successful. And you will see if people, your employees, see value for them, they will speed up the
They will do
implementation.
it. Yeah. And it's
So,
not a
minimum
one-time
to
job.
one, sir.
And
I'm
it's
sorry,
not a
sir.
one-time job. You have to consistently.
Absolutely. See, yeah, and the whole methodology that one cell at a time. Remember, there's a loop where you segment the products and you create cells. It all depends. What will happen is it'll take you less time to implement the next cell because your fundas have become string. You've created a standardized work to implement it. So you should spend time on the first pilot cell and learn everything to the point where if you feel that what, now this sales team has flexible leadership, they change leadership roles, they collaborate on health issues, family issues, they make up for each other, and we have never paid them overtime. They have themselves said, I'll run the job, don't worry, I won't charge you overtime. What's the practice in America? A lot of these machinists, they dog the machine, they purposely slow it down so that they don't complete the order, then they lug out overtime on Saturday. That dishonesty has to stop.
Correct, sir.
So, so I'm sorry, I'm not going to give you an optimistic answer. I'm going to basically say the timeline is continuous, infinity. The speed is in the hands of the company itself, not the consultant they hire.
Mhm.
If you think that getting some McKinsey guy with a suit who'll write you a report for 200 pages is going to give you a transformation, bhul jao. Internally, your team, you have to do it internally. A guy like me can come and say things. I can guide you. Don't rely on me. I'm an outsider.
Correct,
So
sir.
timeline changes. I think that we implemented our first cell at Superior within 3 months. And then in the remaining time, we went one cell by one cell. So we broke up the shop. So they're oil and gas. So one side was small to medium sized parts in high to low or medium volume. So the cells were there. Left side was big parts, long downhole drilling tools, right? Low volume, uncertain demand. So we implemented virtual cells. So we called one side Minion Lane because there are movies, Minions. And the other one we called Monster University because we had monster parts. So 18 months. But again, timeline, sir, I'm not going to say.
Yep. So it takes time. Okay, you
It
should
takes,
not rush. It takes
you
time
should,
and do it
don't rush
properly.
it.
Yeah.
Yes, yes. And have a partnership with the university. Have a
University and then
partnership.
proper team, and then you have
Yes,
a
industrial
partnership.
engineering. Yes,
Okay,
industrial engineering. You know, yes.
fantastic, sir. I think we have a couple of minutes left, so we are already late to the show.
Sure.
So it was fantastic session, sir. One of the most important thing is what I really learned is, so everybody in the manufacturing, they talk about something that is not something we need to look for. What you said is what works for Toyota as a standardized processes assembly line will definitely will not fit you. Okay, so don't think like that. So think you as a separate process, and then fix things for yourself. What works, and then Lean Six Sigma consultant. That I liked it. Okay, because this Lean Six Sigma principles are not only applied in manufacturing, sir, they applied everywhere,
Sure.
healthcare, and now you bring a Lean Six Sigma consultant who is somewhere else working and then come to the manufacturing, that would definitely a suicide. Okay, so I've seen that
Don't
myself.
quote me. Don't quote me because I'm sure I have a target on my back and my head, But Lean Six Sigma, na, देखो, everything I can teach from industrial engineering. Okay. This Lean Six Sigma is just some non-industrial engineer who thought, oh, it would be nice to draw a control chart. Okay. So I'm a cynic, and I will assure you, all that Lean Six Sigma does is it commercializes and makes practical what we have unfortunately in IE made very textbook like. Once we get hands on with our profession, Lean Six Sigma bhaad mein jaye.
Yeah.
I
So
assure you that.
I am a Lean Six Sigma black belt, but
Oh,
I never tell them. I never tell them
only
that we
one
go more on a
Sigma.
practical. We go more on a practice.
Oh, I'm so
Fantastic,
sorry.
sir. No. It's absolutely. I know what we are talking about. Yeah, but we never tell that because we are Lean Six Sigma black belt, we come and improve. I don't believe in that, because what works for you does not work for others. Okay, so you have to find out.
Exactly.
Yeah, you have to
Exactly.
find out what is works for
Exactly.
you, and then do
Yes.
it in a systematic way. Right, as you said, right from the strategy. Okay, so you fix the strategy and then you execute it, and then
Yes, sir.
improve it continuously. So we're fantastic, sir. I think we run out of time. Any
Sure.
final thoughts? Any final thoughts? Any top three takeaways for the business owners, shop
You
floor,
know,
job shop guys?
what would be top three? Top three would be ownership has to learn, hire industrial engineers, do something, with your people, with your shop guys. And don't think that you can sit over here in your office and just wish for improvement when you have no involvement. So it's called skin in the game. Did you allow injury to yourself? So I'm not mocking the leadership, but I'm saying, please, if you are complaining that you're not getting the results you want, but you're like, I don't want to be involved. There's so much good about the Toyota production system, not so much on the tools, but the way of the management, the way that they deal
Management
with
process.
employees. And it was very humbling to me, where it was like, you as the industrial engineer, not a hot shop. Don't go and do stopwatch studies first. You work with the employee, improve the methodology, what I call motion study, improve the work they do, show them respect, then automatically they will say, okay, now you time study me, I will work to that standard.
Correct.
We in India have gone the other way. We
Mhm.
send the industrial engineer, say, time motion karo. So he goes, time study. I looked at the standard. Oh, you know what? You're not working fast. How have you helped the employee? So in India, we have flipped the wrong stuff. We are doing time study first and method study last. Nonsense. Method study should be first, time study should be next. But because management is like cut labor cost, you have a dangerous situation.
Correct. Fantastic, sir. So thank you very much, Dr.
Okay.
Sahab. Thank you very much, and it's a wonderful session. Okay,
Thank you,
so
Ms. Jyoti, also.
I
Thank you.
really
She's the
like.
quiet
Okay,
hero in
so
there.
we look forward, and then we publish the video again. It's live, and so more people attended. We publish it, because many people might have missed it. Okay, so we try to publish it and then share links to all, and it's a wonderful to hear you, sir. Thank you
And
very much.
if people, like I said, if they send you questions,
Yeah,
you neutralize, you sanitize so that I don't have to, you don't have to worry, Arey, Irani went and contacted our, client. But if they have questions, you put some
sure, sure.
code name,
Yes,
or
yes.
if people are willing to fill up the job shop lean questionnaire and send it to me, I'll
Yeah,
do it. But
definitely,
again,
definitely.
I'll do it.
Yeah, yeah. Ladies and gentlemen, thank you very much for attending the talk show. Wonderful. And any questions on Job Shop Lean, please write to us. We will definitely pass it to Dr. Kirani to answer your questions, and look forward for more. Okay, so look forward for more, sir, with some case studies. So thank you very much, and have a great time. Thank you very much.
Thank you.
Thank you,
Thank
Jyoti.
you,
Thank
sir.
you. Bye bye.
Yeah.